Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for the function, determine whether the critical point is a local maximum or minimum, sketch the graph of the function. So let's start with finding the critical point. So critical points are points where the prime of f at x or the derivative of the function is either equal to 0 or undefined. So the first step here is to find the derivative of this function. Now this is a radical function. So the first thing we should do is change the radical into a rational exponent because that will make it easy to find the derivative. So we can rewrite this function as f at x equals, so the radical can be changed to a rational exponent 1 over 2. Now we can find the derivative of this function, so we should use chain rule because this function has an inner function which is x squared minus 2x plus 2, and the outer function is the exponential function with the exponent half. So we start with the derivative of the outer function, so prime of f at x. So for the outer function, we'll have to use the power rule. So we move the exponent to the front of the term, and then x squared minus 2x plus 2, and then we subtract 1 from it, times the derivative of the inner function. So the inner function is x squared minus 2x plus 2. As per the power rule, the derivative of x squared will be 2x. So we move the exponent 2 to the front, and then we subtract 1 from 2, which is equal to 1, and we don't write 1 as an exponent. Now for the second term, the negative 2 is the coefficient, so it will stay as it is, and the derivative of x will just be 1. And the derivative of 2 is equal to 0 because it is a constant. Now we can simplify this expression. So prime of f at x equals, now we can subtract the terms in the exponent. So half minus 1 is negative half. So we get 1 over 2. And we can simplify the last parentheses. So 2 times 1 is 2, and the 0 goes away. So we get 2x minus 2. Now in the next step, we can multiply half by 2x minus 2, and we can move the first parentheses to the denominator to make its exponent positive. So we get 2x minus 2 over 2 times x squared minus 2x plus 2, exponent positive half. Now we can simplify this expression by factoring out 2 from the numerator. So we get 2 parentheses x minus 1 over 2 parentheses now we can cancel out the 2's in the numerator and the denominator. So we get prime of f at x equals, so x minus 1 over so this is the expression for the derivative of the given function. So let's start by finding the critical points at which the derivative is undefined. Now this is a expression in which the variable x is also in the denominator. So this fraction will become undefined if the denominator becomes equal to 0 for any value of x. So for that, we'll sub in the denominator expression equal to 0 and then find the x values that will make the denominator equal to 0. So we should do x squared minus 2x plus 2 equals 0. So we have to solve this equation to find the x values that make the denominator equal to 0. Now this is a simple trinomial, but we cannot factor this expression, so we'll have to use quadratic formula. But what I observe about this trinomial or quadratic equation is that its discriminant is negative. So as you may remember, discriminant tells us the number of roots an equation has. So its formula is b squared minus 4ac, and for this equation the b value is negative 2 and minus 4 times the a value is 1 and c value is positive 2. So now we can simplify this expression. So negative 2 squared is 4, and then 4 times 1 times 2 is 8, and 4 minus 8 is equal to negative 4. So that means this equation, the expression in the denominator, has no x value that will make it equal to 0. So that equation has no solution. So that means there are no x values that will make the denominator equal to 0, or no x values that will make the prime of f of x undefined. So the next case we have to explore is the x values that will make the prime of f of x equal to 0. So we'll sub in the left side as 0 and then solve for x. Now we can cross multiply the denominator. So 0 times any term is equal to 0. So we get 0 equals x minus 1. And now we can isolate x by adding 1 to both sides. So the ones on the right side will get cancelled out. So we get x equals 1. So this is a critical number for this function. So at this critical number, x equals 1, the prime of f of x becomes equal to 0. Now we have to find the function value for this critical number to find the critical point. So we should sub in x as 1 in the given function. So we can do this here at the top. So f at 1 is equal to the square root of, so 1 squared minus 2 times 1 plus 2. So now we can simplify this expression. So f at 1, so 1 square is 1, 2 times 1 is negative 2, and then plus 2. And negative 2 plus 2 is equal to 0. They cancel each other out. So we end up with square root of 1, which is equal to 1. So that means the critical point for this function is 1, comma 1. So this function has only one critical point. So we are done with the first part. Now we have to determine whether the critical point is a local maximum or minimum. And for that we can use the first derivative test. So the first step is to find out the intervals on which this function is increasing and decreasing. And for that we can use the number line method. So this critical number divides the number line into two parts. So we can show the critical number. So x is 1. So this critical number divides the number line into two parts, and we have to find whether the function is increasing or decreasing in these two parts of the number line or these two intervals. So for that, we'll use a test value in each interval. So on the left side of 1, we can use the test value 0, and to the right side of 1, we can use the test value 2. So now we should sub in these test values one by one in the prime of f at x to find whether the prime of f at x is positive or negative in these intervals. So we know that if prime of f at x is greater than 0, that means the function is increasing in that interval. And if the prime of f at x is less than 0, that means the function is decreasing in that interval. So we'll use this expression for prime of f at x. So we'll start by subbing in x as 0. So prime of f at 0 equals, so 0 minus 1 over then 0 squared minus 2 times 0 plus 2 and then exponent 1 over 2. Now we are not interested in the value of the prime of f, we are only interested in the sign of the value. So whether we get a positive or a negative result. So prime of f at 0, so the numerator is negative 1, and in the denominator, so 0 square and 2 times 0 will go away because they'll become 0. So we'll be left just 2 exponent half. So the numerator is a negative value, the denominator is a positive value, so the overall result will be a negative value. That means the prime of f to the left side of this critical number is negative. That means the function is decreasing on the left side of this critical point. Now we can analyze the other test value. So prime of f at 2, so we get 2 minus 1 over, so we get 2 squared minus 2 times 2 plus 2 exponent half. Now we can simplify this expression. So prime of f at 2, in the numerator 2 minus 1 is just 1, and in the denominator, so 2 square is 4, then minus 4 plus 2 exponent half. And now we can reduce this expression to just 1 over. So in the denominator we are just left with 2 exponent half. So we are left with an overall positive value. So that means the function is increasing on the right side of the critical number x equals 1. So now we can use these results to find whether the critical point is local maximum or minimum. So at the critical number, the function is changing from decreasing to increasing as we go from left to right. So that means there is a local minimum at the critical point 1, 1. So this is a very important concept you need to understand and memorize. So now we are done with the second part, and now we can sketch the graph of the function. So for that, we should first identify the intercepts because that will make the sketch more accurate. So we can start by finding the x-intercept of this given function. So for x-intercept, we sub in the function value equal to 0 and solve for x. We get square root of x squared minus 2x plus 2, and now we can square both sides to get rid of the square root. So we get 0 equals x squared minus 2x plus 2. Now, as we figured out earlier in the first part, there are no solutions to this equation because its discriminant is negative. So there are no real solutions. So that means there are no x-intercepts. Now we can find its y-intercept. And for that, we will sub in x as 0 in the given function. So f at 0 equals square root of, so 0 squared minus 2 times 0 plus 2. And now we can simplify this expression. So the first two terms go away. So we are left with just f at 0 equals square root of 2. So that means the y-intercept is 0 times square root of 2. Now square root of 2 is 1.414. So that will help us plot the point. So 1.41. So there is only one y-intercept. So now we can use all of this information to sketch the function. So let's start with the grid. So I'll draw the grid. So we can show the critical point, which is 1, 1, and it's a local minimum. So let's assume 1 is here on the x, 1 is here. So the critical point is here. Now we also found the y-intercept to be at 1.414. So it will be somewhere here. So these are the 2 points we know that lie on this function. Now we can use the results from the first derivative test to sketch the graph. So on the left side of the critical number x equals 1, the function is decreasing because we got a negative value for prime of f. So that means as we go from left to right, the graph should be sloping downwards towards the local minimum. So this is the sketch on the left side of the local minimum. Now on the other side of the local minimum, so the graph should be increasing because as per the first derivative test, the prime of f is positive on the right side of the critical number at x equals 1. So the graph should slope upwards on the right side of this critical point. So this is the sketch of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.